All right, so today we're looking at unit rate. For unit rate, there's a couple vocabulary terms that we're going to be using a lot, so it's worth writing down. The first one is ratio. A ratio compares two different quantities, or you could think of them as like things. So it compares two different things like boys to girls, or students to desks, pens to pencils, teachers to students. So it compares two different things. A unit rate is when a quantity has 1 as a denominator. So when a quantity has a denominator of 1, it's like how many pens per pencil, how many students per teacher, how many kids per desk. So it's for one of that second thing. How many apples per pound? So per one of something. So those are the definitions that we're going to be using a lot today. Things like ratio and then unit rate. They're slightly different. The first example is going to be dealing with me mowing a yard. So Mr. T can mow.
Do you mow the yard?
I do mow the yard. 3/8 of an acre.
My dad won't let me.
In 45 minutes. So Mr. T can mow 3/8 of an acre in 45 minutes. Our question then is, how many acres per hour? So acres per hour means how many acres in 1 hour, per 1 hour. So I'm going to write the ratio of acres to hours. So it is 3/8 of an acre over 45 minutes. So I wrote the ratio of acres to minutes, but we want acres to hours. So we have to change 45 minutes and convert that to hours. What is 45 minutes converted to hours? Think of a clock. Where's 45 minutes on the clock? Here, right? So that represents 45 minutes. There's 30 minutes. There's 15 minutes. There's 15, 30, 45. So what fraction of the hour is it? 3/4. Now we have our ratio of acres to hours. Now we can find acres per hour. In order to find the unit rate, we divide. Numerator divided by denominator. We're going to copy, change, then flip. So once we've got our fractions, we can multiply. We can reduce. 3/3 reduces to 1. 4/8 reduces to 1/2. Multiply straight across. That'll be 1/2. So I can mow half an acre per hour. So we do get to use calculators here in Unit 2. I'm going to be using the calculator to check our work because we're actually really good at fractions, so we don't have to use them, but it's nice to have them just in case. So to type in a fraction on our calculator, we'll do 3 ABC 8. That little symbol there in between the 3 and the 8 is showing that it is a fraction sign, so I'm going to do 3 over 8, and then I'm going to do divided by 3 ABC 4. So that's 3 eighths divided by 3 fourths. Then I'm going to hit equals, and that gives us 1/2, which is exactly what we found. The ABC button is that one right there below probability. Yeah, AB. All right, let's look at a second example. Olivia hikes 2 3/4 miles in 1 hour and 15 minutes. So Olivia hikes 2 3/4 miles in 1 hour and 15 minutes. The question, how many miles per hour? So our ratio is miles per hour. So I'm going to do 2 3/4 miles over the hours, 1 hour and 15 minutes. So we got 1 hour, and then we got to change 15 minutes into hours. How many hours is 15 minutes? 1/4. Good. So now, to find our unit rate, we divide numerator divided by denominator. 8, 9, 10. That gives us 11 over 4 divided by 5 over 4. 1 and 4 plus 1. Then I'm going to copy, change, and then flip. My 4's cancel. Gives me 11 over 5. Which then reduces to 2 1/5. So Olivia hikes 2 1/5 miles per hour. And that is a commonly used abbreviation for miles per hour, MPH. You probably have seen that on road signs and cars before, miles per hour. And we can check our work with our calculator. So when we put in our calculator 2 3/4, we're going to do 2 ABC 3 ABC 4. That's going to give us our units and our fraction, 3/4. So 2 3/4. Then we're going to divide that by 1 1/4. So that, get out of the light. So that gives us 1 1/4. So when we divide that, that gives us 2 1/5, which is exactly what we found when we did it by hand. All right, let's look at a third one. So after half an hour, a pool leaks 7/8 of a gallon. So our question, how many gallons per hour? So after half an hour, a pool leaks 7/8 of a gallon. How many gallons per hour? I'm going to give you a minute to solve that. Anybody think they found it? Yao?
1 per hour.
1 3/4? Anybody get something different? Selena, Samara, what'd you get?
4/7.
4/7. So 4/7 and 7/4 is what, because you got 7/4, right, Yao? And then you converted it? Okay. Here's what some of you did. If you got 4/7, here's what you did. 1/2 over 7/8. Right? What mistake did they make? What mistake did they make if they did that fraction right there? It's a common one. Molly?
They put the hours in the numerator instead of the denominator.
Right. We want our ratio to be gallons per hour. So we want our gallons on top and our hours on bottom. That is a very, very common mistake that people have. Make sure that you see in the question what our ratio is going to be. So we want to know how many gallons per hour. So gallons per every 1 hour. Now we divide. Numerator divided by denominator. Copy, change, flip. And we can reduce that. So we do 7/4, which reduces to 1 3/4. So it's 1 3/4 gallons per hour. So our last example is probably going to be the most important. This is what we're going to be using unit rate most often to solve. We'll do distance as in miles, and then we'll do time and hours. It's the most common. We'll make a chart here. So in this chart, I'm going to fill in some information but leave some of it blank. And we have to find the missing pieces. So we have a situation here where somebody's running or somebody's walking or something, biking, jogging, whatever. They're traveling 3/4 of a mile in 1/10 of an hour. It tells us that in our chart. Based on that information, how long is it going to take them to travel 1.5 miles? Based on that information, how many miles are they going to travel in 3/5 of an hour? How could I solve this? Think about what we did up above here for these problems. How could I use the information that I found before to apply it to this new problem?
You could, for the first one, you could divide the distance by the time, and then that tells you how much it is for one, and then you could multiply it by the distance.
I think that's a great idea. Let's do that. So what I'm going to do is exactly what Molly said. I'm going to do 3/4 and divide that by 1/10. That gives me 7.5. So that tells me it is 7.5 miles per hour. This is our unit rate. That's how quickly they're traveling per hour. So every hour they're traveling 7.5. So if they're traveling 1 hour, I do 1 times 7.5. 2 hours, I do 2 times 7.5. 3 hours, I do 3 times 7.5. So if I take the time and I multiply it by 7.5, it'll tell me the distance that they traveled. The inverse of that is also true. Think of it like when we did 3 times 5 equals 15. The inverse of that is also true. 15 divided by 5 equals 3. So if I do time times 7.5 equals the distance, that means that the distance divided by 7.5 equals the time. Molded mind, man.
T equals RT?
Yeah. We're not quite there yet, though. So,
Language arts is math. Math is language arts. Mr. Thompson's using language arts right now.
I am using language arts.
How can he get stuff in his head? Not all of it. How can he get the stuff in his head that he wants to get out of his head and into your head? And he planned that out. And he's using the art of language.
I am.
He's good at it.
I've tried. So, this is really where we're going. We're going to put a lot of emphasis on this. What this is the constant rate. That's what the rate is. Every hour he's going that distance, that many miles per hour. So in order to find these missing pieces, I'm going to use that rate. So to find the time here, to find the time, I'm going to take the distance and I'm going to divide it by 7.5. So I'm going to take 1.5, and I'm going to divide it by 7.5, which will give me 1/5. So in 1.5 miles, it should take him 1/5 of an hour. We used our unit rate to find that. It's what? 30 minutes would be 1/2 of an hour. 1/5 would be like 20 minutes. Here I'm looking for distance, so to find the distance, I'm going to multiply by time. So I'm going to do 3/5, and I'm going to multiply that by 7.5. Which gives us 4.5. So 4.5. This is where we're going to spend, like I said, a lot of time. We're going to be using these formulas to help us to find missing pieces. We're going to be using these formulas to graph on 4-quadrant graphs. We're going to be using them to solve complex problems, and including things like complex fractions, so fractions within fractions.